All right, so it was 23rd August when the mission 217 set off for Mars to spend 14 souls on Mars. Here we landed on Mars successfully. Then I myself I am an analog astronaut and the engineering center. Let me tell you a little about engineering center. Engineering center is very vital part of facility on Mars because it is really important for the in-situ resource utilization so that we don't have to import everything from Earth to Mars. And it is also very important for construction and maintenance purposes and repairing and innovation as well. Next, let me share the internal design with you, which I would have to again um, share my other screen. Just give me a moment. I hope my screen is visible.
Yes.
Okay, so this is the like small facility that I have made in by using the Creo parametric software. We'll just hide, and this is how it looks like from the inside. I will show you the ground floor now as well. Okay, so this is the ground floor, and this over here is the decontamination, or we call it the dirty lab, where which is attached to the airlock. And when you come in, you can experiment with the samples that you have brought from outside. And then we have like a medical bay right next to it, so you guys can test yourself of any type of viruses that you might have brought in from the expedition that you were on. And then next to that, we also have like the LSS room where the life support system is, and also the like the recycling water plants are there, and like the desalination and everything. Apart from that, we also have like an engineering bay over here, and here we can work on all our EVAs, and we can fix rovers, and we can also create them. Then at the back, we have like a storage unit where we can store any tools that we might need. Next, I am going to show you guys the middle floor. So this is the middle floor where we have like a hygiene room over here, like the toilet. There is only one toilet in our facility, and this over here is like the clean lab. The clean lab is basically the lab which contains all the really important equipments like 3D printers and everything. We can also use this to experiment after we have cleaned everything in the decontamination lab, or like the dirty lab. Then we also have this monitoring room, or like it has all the computers and all the equipments which are needed to connect with Earth or with other facilities as well. Then we have over here, we have the the recreation room, or you can also use it to exercise and all. Now, as I will show you the top floor. This is the top floor, and I have connected all three floors with a ladder, which you guys can see. Then we have three individual sleeping quarters for, as we only have three astronauts in our facility. I have added three individual bedrooms or sleeping quarters. And next over here, this area is like the cupola, or like the quiet zone. Here everybody can sit and just enjoy the quietness. And then this is like the library. I haven't added any shelves over here, but it's a really important place for where you can self-reflect. And next to it, we have like the kitchen. This is the kitchen. Sorry if it looks a little funky. I'm kind of new at this. But and then here over here, this is like the hydroponic system, which I have integrated within a wall so that we can easily grow all the plants within the facility. We won't have to depend completely on the greenhouse for supplying us with food. We can also grow some of our own as well. And this is how it completely looks from outside. And I will stop presenting this to present the next thing. Okay. Now that we are done with the internal design, we will move on to the applied technologies, which will be presented by my partner Valeria.
Yeah, okay. Can you hear me?
Yes, you are audible.
Oh, okay. So, sorry for not having my camera, but I have some issues with it. So, I will start anyways. So, the applied technologies. Here in the presentation, it is summarized, but I will try to explain each one of them. So the applied technologies in the engineering center is based on a combination of life support, energy, monitoring, and production systems that allow for extensive living and exploration in insulation. So each one of them is intended to reduce the reliance on Earth, and also all of this while protecting our crew and their health, etc., safety, and also to extend possible productivity. So, first one would be life support systems that there are always going to be some algae bioreactors and air scrubbers. And what does this mean? Well, what happens is that the air scrubbers are constantly recycling the air. And what happens with the algae is that it generates oxygen because of the photosynthesis and also consumes the CO that the crew produces. So that is something really positive. And air scrubbers also collect remaining carbon dioxide and trace contaminants. So this makes ensuring they breathe easily in the habitat. Next, we have the energy systems that it's large mounted solar panels collect clean energy, which is stored in a high capacity rechargeable batteries. So this guarantees a constant power supply even in fluctuation day, night, or cloudy conditions. So with this, energy partitions are tuned, such as through an energy management system. So for routing to any essential systems that we have in the engineering center, so like life science, safety filling, and communications, as an example. Then we have the hydroponic and algae-based food systems. This is other fast yield crops. Uh, it is made from leafy greens to flowers. So what happens with this is that they are grown in hydroponic gardens with no soil. So that makes it easier to grow up without needing anything else. And also using nutrient-rich water solutions and algae integrated systems make edible biomass and also help to do oxygen, as I already said you with the life support system. And um, also, such systems lower dependence on earth provided food, so while further healing the earth system. Then we have the 3D printing units, and the multi-material 3D printer enables the crew to economically produce spare parts, tools for repairs, and specialized equipment, and such as maybe emergency medical equipment for any emergency it can happen at the mission. And also the printers also cut and waste the number of resupply missions by recycling polymers and composites. And next, we have the digital monitoring network that this network of AI sensors monitors real-time habitat conditions, and like the most important ones that would be definitely temperature, humidity, air gases, and water quality. And also something very positive of this is that it tracks crew biometrics and can send out alerts if something is off or something is wrong with it. So you can be and have an alert about what is happening. And also, it's a predictive analytics that help equipment failures before they reach critical status. So you can prevent with this many accidents or issues on the mission. And last one, we have the water recycling system that, for example, sinks, showers, and hygiene stations use great water, as you know. So all of this is filtered, treated, and passed with microbial controls. So uh, after this process, it is purified to provide 100% non-potable water. And that significantly cuts water use and provides a sustainable closed loop cycle, which is crucial for lengthier trips. So, together, in conclusion, these machines and technologies offer autonomy, adaptability, and redundancy, and some of the most important characteristics of analog simulations on Earth and future settlements on the Moon or Mars. Thank you.
Hmm. All right, so I will take this slide, and Valeria, you can continue with the rest of it. Okay, so for energy generation, these were a few of ideas which I came up with. We can use like SBSP, which is like space-based solar power. We can deploy the solar plates or solar panels. We can like integrate them with satellites, and we can deploy them outside the surface of Mars. And the electricity produced there can be transported to Mars via microwaves or laser. This is also a very credible idea like um, which could be used here on Earth as well. Apart from that, there are also like fission surface powers, which is basically like a small nuclear reactor. They split uranium atoms and convert the heat produced into electric power. Then we also have like microbial fuel cells, because there are some like bacteria which are electroactive. They when they eat or like organ when they organize oxidize organic matter, they actually release electrons, and these electrons can be used to make electricity. Some of the examples of the microbes or like the bacteria are Schwannella and Geobacter. Right. Would you like to continue, Valeria, or should I continue?
Um, it's fine for me. So then we have resources in situ and versus the air supply. And first, we have locally generated resources for the analog simulation. Then we have plant-based food production via hydroponics, oxygen supplementation from algae and vertical farming systems, water recovered and purified from gray water systems, air supply resources, specialized medical kits and pharmaceuticals, complex electronic and computing equipment, processed nutrition for backup and emergencies, and I can really see last one, but it would be processed nutrition for backup and emergency, seeds and microbial cultures for farming systems, and all this strategy is to minimize earth dependency by testing closed loop systems while retraining critical air support for reliability and crew safety.
Then I will talk about the management. All right, so the organizational structure was made for like three members, as we are only three astronauts. So we decided on making an organizational structure which is one, hyper efficient, based on extreme cross functionalities and mixed with like situational leadership. So I have made like the organizational structure like an inverted T, with like the mission commander who is also a mechanical engineer, and then the medical and the systems engineer, and also like the avionics and software engineer. Next, this is the astronaut and the astronaut profiles and the responsibility. This is actually my favorite slide because it has all of our pictures. And basically, there is, first of all, there is Sibga Anwar, who is me, and I am basically in charge of, my primary responsibility is to um, ensure the crew's safety, mechanical integrity, and fabrication and EVA lead. Also, my secondary responsibilities are to handle power systems and structural aspects, and my tertiary responsibilities are to be like a good medical assistant and understand operational software as well. Then we have Valeria, who is a sustainer. Her primary goal or her primary responsibility is to ensure crew's health, make sure that ECLSS system works properly, food production and biological research as well. Then we have secondary responsibilities of Valeria, which is she has to handle the chemistry and lab analysis and also assist in the mechanical activities. Then her tertiary responsibility is to just be a general maintenance assist. Then we have Biswajit. He is the technical visionary. His primary responsibility is to design structure, software, and automation. Then we have his secondary responsibilities, which is ISRU process monitoring, ECLSS, and data management. His tertiary responsibilities are to be a mechanical assist and medical monitoring as well. So our main like motto or like tagline is an expert in one, a proficient in other, and a capable assistant in all. Because we are only three people in this facility, so we decided on having this type of like organizational structure, so that one person is like an expert at something, extraordinary expert at something, and then he is also proficient in something else as well, and then a capable assistant or able to assist in any type of like responsibility that might be given to him or her. Then we have astronaut training program. All the training that are really important include technical, psychological, and physical preparedness. We first of all have technical training because we all we all should know that how to know how to operate the life support systems, 3D printers, power and water recycling systems as well. Then we also have psychological training because we are on Mars and there are not much people around. So we have to learn how to deal with stress management and mindfulness and group conflict resolution. Then we have physical preparedness. It is really important to have like a fixed fitness routine which is tailored according to confined spaces, EVA simulations, and use of resistance based equipment. Then we have emergency drills, which are really important as well. These should be done at least twice or thrice a month. And then we have field analog activities, which is survival training in deserts or Arctic like environments to replicate extreme conditions. Moving on, these are some YouTube videos that we have added for the astronaut training. If you guys want, you guys can take a screenshot as well. Next, this is like a small like bonus thing. A day at the engineering facility. Let's say there was like a problem. I am now going to give you an example of how the organizational structure is going to work. Okay, so our day starts with breakfast, followed by daily exercise and daily checks around the habitat. Then a briefing session, which includes we have like a problem that we have to solve. We need a new storage module. It must be 5 meter by 5 meter, which it should be able to withstand a pressure of 1 kilopascal, dust storm, and connect to node 1 as well. So our architects or like our structural engineer, who is Viswajit, he will design the module in CAD, he will also run wind and dust simulations on the design and perform stress analysis on the structure and connection points. Then the commander, She leads the EVA to deploy and monitors the printing and assembly robots while the architect assists, whereas the sustainer will have the important responsibility of checking or monitoring the both of the astronauts vitals and also work on the development of life support systems at the unit that we are going to create, or like the storage module that we are actually creating. Let's move on. So these are like the resources of for 1 week. As we are three astronauts, so I have only listed the resources which are required for three astronauts. I have made it into a table. Let's move on. Now, guidelines for other stations. First of all, the first and main guideline is standardized resource sharing networks, unified safety and emergency codes across facilities, shared communication protocols for real-time coordination. Because obviously, communication is very important, especially when you are um, really far away from like Earth. It is really important that you have communication with not only the facilities around you, but also the people on Earth. Then there is also mutual training exchange between different habitat modules. This ensures that the facilities operate not as isolated units, but as a part of a cooperative station-wide system. And also, this is my favorite thing, fun is mandatory. we uh, we are we have to conduct at least a 30 minutes gathering at the main station at the end of the day after dinner, so that we can get to know each other, and we can know who else is here on Mars with us. Next, we have the protocols. I'm sorry for the spelling, but Valeria will continue from here.
Okay, so as the protocols, we developed 14, so it's a very extensive, but I will try to explain you all of them so it's easier to understand because we wanted to develop protocols for each area because it is important to have specific rules to know what to do. So as first, we had the site safety protocols, and we have specifically five of them, and we have protecting the crew and habit integrity. I think this is the main and the most important, because it will be always important to protect our crew. And when I say protecting our crew, it means their safety, their health, their environment, and everything. Then we have defined safe working zones and restricted areas, and more specifically, energy storage, medical bay, and the 3D printing lab I already mentioned. Next, we have emergency exits and escape routes marked with illuminated indicators. This, I think that in any situation, it's really important because maybe it can happen any issue or something, so we should be aware of that. Next, we have a radiation shielded shelter accessible within 2 minutes from any locations. So as crew, we can be safe, and very important that it should be within 2 minutes from any locations. So whenever it happens something, we are able to go in less than this time. And also we have a weekly inspection of fire resistant panels, oxygen masks, and extinguishers. Also very important. Next, we have the dust and debris mitigation protocol. This is to maintain cleanliness and our equipment reliability. Uh, Here we have four protocols. The first one would be airlock procedure, that the crew must remove outer clothing and vacuum dust before entering. This is very important because maybe in this protocol we can prevent any issue of sickness and all that stuff, because outside sometimes it could be contaminated. So uh, removing our clothes can prevent that. Next, we have the ventilation system fitted with HEPA filters, and these should be replaced monthly. Also, a daily cleaning schedule for labs and sleeping pods with antimicrobial wipes. As I said, all of this is to prevent any issues that we can have with outside, because it should be very important for us to keep cleaning our environment. And also, waste stored in sealed containers and transferred to recycling processing unit. This is also really important to keep organized and don't let uh, other things. Maybe it could happen that some trash may be in there, so it should be really important to have a structure of where we have to put our things. Next, we have our environmental monitoring protocols. Here we have 5. The first one will be ensuring habitat stability and safety. Like I said, this is kind of the same as the first one I mentioned to you, that we should be always be being focused on our environment, the habitat, and always try to optimize any procedure we have. And then we have continuous AI monitoring of air composition, like as the applied technologies. This is like the protocols we should focus on when we are seeing our applied technologies. And for example, it would be O2, the carbon dioxide and trace gases, our temperature, humidity, and air pressure, most important things to check up. Also, the water recycling purity always should be checked for microbial and chemical balance. Then, radiation sensors provide real-time exposure data, and also a weekly calibration of sensors with diagnostic test logs. Next, another of our protocols would be autonomous and remote systems, and this would be using automation for safety and efficiency. Also, a AI-driven monitoring system predicts failures before they occur. As I already explained you in the applied technologies, we will always try to monitor and prevent any issue that could happen. Next, we have our remote dashboard accessible to crew and mission control. This is also something really important. Like I already said, you, I think for protocols, it's very important to have a structure of what we have to do and follow these rules in order to have a good habitat. Also, we have the remote dashboards accessible to. Oh, I already said that. Sorry. So we have the robotic arms and drones inspect structural integrity in hard to reach zones. So we can continue seeing and monitoring if there is something different each day, or if we can find any issues or problems to solve up. And last one, we have automated daily backup of mission logs, crew biometrics, and technical data that having this as a daily backup would give us information on how can it evolve, let's say like that through the days, so we can have a track of the evolution that each one of the crew has. Next, we have um, our crew safety and evacuation protocols. With this, we are trying to prevent having any accident or all that kind of stuff. We wanted to be prepared for any kind of situation that could happen. And first one, it would be an emergency preparedness for survival. This is a kind of medical kit in order to um, I have repeated these words many times, but we should be prepared for any issue. So each one of these protocols, it's based on anything that could happen at the mission. Next, again, we have evacuation maps with illuminated CH to safe compartments. We have also radiation shelter stocked with oxygen tanks, water, and emergency rations. I already say you um, we should be prepared for anything. So I think this is one of the most important because we'll never sure of what can happen or anything. Also, we have fire, pressure loss, and radiation drills practiced weekly because this is very important for our crew to know if there is something to happen. We have also something very important. It is the biometric monitoring alerts and AI during crisis. So we are able to know what to do if anything happens. And each crew member certified in medical first aid and technical emergency repair. I think this is something really important to know about because each one should know what to do in any kind of situation. So I think not only as astronauts, just as persons, it should be really important to know medical first aid. Next, we have our installation specific routine protocols that first we have the structured daily and weekly schedules, like um, some like um my partner explained you. It's really important to be organized and the daily routine also structure with steps so um, we can optimize our time and don't waste anything. So it would be hygiene, exercise, the habitat system checks, and also through midday. Probably this always can change. It's it will be based on what we need and the evolution of the mission on what we are trying to do, or as Sibja said, that based on the problem we have as a crew, this routine can also change. At midday could be research, the engineering maintenance, hydroponic monitoring, group meals, log updates, recreation, physiological check-in, and for our weekly routine will be deep cleaning and sensor recalibration, water recycling flush and microbial check. That's one of the most important. And group resilient activities like team discussions to talk about what we think we can do better or what kind of procedures we can do enable to complete the missions. So we're almost done. Now we have the security protocols that uh, the main idea of this is to prevent any risks. And for this, what we would do is the biometric authentication required for critical systems like power, life support, or medical. AI detects suspicious access attempts or irregular patterns. And all of this compartmental lockdown system seals out damaged or contaminated sections. And lastly, radiation storms trigger automatic red alert lockdown of habitat. Next, we have our communication protocols that these are for ensuring continuous connectivity. For this, we would do daily logs sent to mission control, internal message archive for accountability, weekly tests of backup communication systems, like, for example, satellite uplink, shortwave radio, and something that we something that we developed really important. It will be emergency codes, like for example, color coded signals and anything that we would be helpful for us. Next, we have our maintenance protocols, and this will be keeping systems reliable and functional. Daily inspections of light support, energy storage, and hydroponics, weekly system diagnostics for AI, the 3D printers we mentioned in the applied technologies, the recycling loops, the critical spares manufactured by via 3D printing and logged in inventory. And also failures categorized as critical, medium, low, and to see in which one we have to prioritize. Then we have occupation entertainment protocols. It would be presenting mental health and social cohesion. And we add this one and develop it because, as Sip just said, in our routine, it would be really important to discuss as a crew and share our ideas of what we are thinking, what we can do, and all that stuff. So it would be like group activities, shared meals, storytelling, VR simulations of Earth, maybe cooperative games. And we have personal activities like reading, writing, painting, private VR sessions, physical activities like resistance, exercise, yoga, anything that any one of the crew wants, mindfulness, daily meditation, or breathing exercise to reduce stress, and weekly recreation, group movie night, or collaborative creative projects. Next, I'll try to speak it a little faster because this is a lot. But then we have the food micro production protocols. We want to sustainable farming, food for food and oxygen, hydroponics, crops grown in nutrient solutions, monitor daily for pH and mineral balance, fast growing plants, that it could be lettuce, spinach, herbs, and microgreens that are harvested every 7 to 10 days, maybe. And then we have again the algae bioreactors that we should have a daily monitoring of light cycles and biomass density for the best results. Then we have the harvest every 3 to 4 days for supplemental food and oxygen release. Fresh procedure incorporated to process meals for nutrition and moral, and AI track yields and predicts shortage. Next, we have our 3D printing protocols that it would be more specifically as medical and structural tools. First would be producing critical supplies on demand. Next, design and approval. Crew selects preloaded blueprints like splints, clamps, reinforcements, and an IA abilities designs parameters before print. Printing process material include polymers, composites, and recycled plastics. And also we have chambers sterilized before printing medical equipment. Post-production, there will be items inspected for structural flaws and sterilized before use. Log into inventory with usage notes. And as last one, we have emergency printing, and that AI initiates printing if its stocks of critical items drop below the threshold.
All
Yeah.
right, Biswajit, you can start.
Yes. Am I audible?
Yes.
Hello. Yes. Okay. So as we move towards the end of our presentation, the last topic that we are on the point to discuss is the spin-offs. So starting with the Earth application, what we develop for space doesn't stay in space. It finds powerful uses here on Earth. Closed loop recycling can reshape urban sustainability, while circadian lighting brings healthier rhythms to our homes and workplaces. Imagine origami inspired shelters quickly deployed after disaster, or AI driven monitoring system transforming the way our smart city functions. Space solutions are, in fact, Earth solution in I can say, advancement. Uh, yes. So moving to the next slide, we have guidelines for daily life and research focus. Space teaches us discipline, structured routine, greenery indoors, and adaptive lighting. These aren't just astronaut tools, they are everyday practice for resilience. Similarly, research into isolation, closed loop systems, and new material prepare us for both space habitats and future cities. Even AI becomes a predictive partner in keeping life systems sustainable and suitable. You can move to the next slide. Now, the next thing that we need to talk about is the impact of sustainable development goals. Every innovation ties directly into the UN Sustainable Development Goal. Stress monitoring, like good health solar energy drives clean energy transition. Modular construction fuels resilient infrastructure and adaptable housing support and sustainable cities. At the heart of it, closed loop systems ensure climate friendly action. The roadmap to space is also a roadmap to the sustainability into the earth. So the last thing that we have is the management system and quality of life enhancement. But beyond survival, it's about thriving. So central AI dashboard anticipate needs before they become a problem, while we can incorporate storytelling, mindfulness, and downtime ensure mental balance. In space, as on Earth, true sustainability means not just efficient system, but nurturing human creativity, well-being, and joy. So yeah, that's all that we have for the presentation. Now we are open to any questions if you guys have.